Grade 7, this is 3.5. This is building on from two-dimensional shapes to three-dimensional shapes. We're looking at total surface area of rectangular prisms. And what that means is we're going to be calculating all the faces, and there's 6 of them, and then adding it up. Essentially, that's what we're doing today with this lesson. Let's go through it. The first thing, let's just do a little review. How do you calculate the area of a rectangle? And again, when we're calculating area, we're thinking about the amount of space that it takes up right here, like that. And we're only given 2 variables, a length and a width. So area is calculated by length times width. The trick to finding the area of a rectangular prism is actually to break it into its net. And if you look over on the right hand side here, you can see the net that I've done. I've taken this three-dimensional shape and I've unfolded it like it's over paper. And once you've figured this out and you can see it as a net, it makes it a little bit easier because you're just calculating the area of all of the rectangles. There's a rectangle, there's another rectangle, another one, another. In fact, how many rectangles are there total? No, there's 6 of them. And once you've calculated the 6 of them and add them together, that's your area of the entire rectangular prism in this case, or a cube for the same thing. The thing is, it's a little bit easier than that because some of the faces are actually the same. When you look at the top of a prism, a rectangular prism, and you look at the bottom of the prism, those are actually the same because it's the same dimensions. The front and the back are the same, and the left and the right are the same. So in reality, there's only three surfaces. There's the A, there's the B, and there's the C. The A, the top, and the bottom are the same dimensions. So if you calculate the area of 1 and then double it, you've actually got the top and the bottom together. The same goes for the front and the back. The front dimensions are the same as the back dimensions. So if you calculate the area of the front and double it, you get the front and the back. Same thing with the left and right. So in practical purposes, what we're going to do here is we're actually going to label these. We're going to call this one C, and call this one B, and C, and I'll explain why in a second. B, and then A, and A. So when you look over on the this diagram right here, the A is 2 units of 2 or centimeters by 4. And this side, or this part of the net, is the exact same size as this part of the net. It's a 2 by 4 and a 2 by 4. So we're going to call that one A because they're the same. Let's look at the B. The B is 3 by 4. And we look down here, we see another one that is 3 by 4. And that is our B. And even though you don't see the number 3 going across right here, we know it's 3 because you see this line right up here. That length is 3. That means that this length is 3, that length is 3, and that length is 3, and that length is 3. The last one is our C. The C, this area right here, is 2 by 3, which is also replicated right here at 2 by 3. Remember what I said about how opposite faces are the same? Well, if you roll this net back up into a rectangular prism, you would see that this face is opposite to this face, and therefore they're the same, and that face is opposite to that face. So we calculate the area of each rectangle. So we're going to calculate the area of the A's, and it's just length times width. We're going to calculate the area of the B, and then we're going to calculate the area of the C. And it looks a little like this. The area total, which is the area of the entire outside faces of the sum of all the faces of the rectangular prism, is the area of A, right here, plus the area of B, right there, plus the area of C. Now why do I say times 2? And think about it for a second. Why would I double it? I've done the area of A, the area of B, and the area of C. But I have to double it, you've probably figured it out now, because there are 2 A faces, there are 2 B faces, and there are 2 C faces. So it's 6 faces total, like we said at the beginning of the lesson. In this case, the area is 52 centimeters squared. Try this one. We have a length of 3, we have a width of 2, and we have a height of 5. Instead of drawing out the net this time, we're going to go a little bit differently. We're going to write down the formula, because that's what we're trying to do. So we got 2 times, well, this is L, and this is W. So we're going to say length times width. Then we're going to add an L times height. So length times height. And what's the only other set of variables we haven't used yet? We haven't used the W and the height. W and the height. Sorry, my writing is a little bad here. Once we've done those three calculations, this is just a little bit faster, but you have to understand what we did back here, which was we separated this into 6 faces. That's what we're doing in this little formula right here. We're actually calculating each face, length times width as a face, length times height as a face, and width times height as a face. And then, like we said on the previous slide right here, we have to double it because there are, in fact, 2 of each. So try to calculate the area of this. Pause the video. I'll reveal it now. 62 centimeters squared. Try these 2 on your own, and that's it. Take care.